Hello everyone. Here we can see representation real number on number line. How we can represent the real number on number line like that. So first of all, in previous section you have seen real number has a decimal expansion. So here, what is the topic of us? That is real number representation on number line. So we write here that is a real number representation on number line on number line like that. Okay, so when we solve real number representation on number line, then first option for decimal expansion. What is first option for decimal expansion? That is if a decimal expansion is a terminating nature or non-terminating nature, like that we can explain different condition of a rational number. In the previous section you have seen that any of real number has decimal expansion, and this help us to represent it on the number line. Let us see how. Suppose we want to locate 2.665. If we want to locate on number line, that is 2.665. Here is 2 and here is 3. We want to locate 2.665. How we can represent 2.665 here on number line? 2.665 like that. Okay, so let us look closely at the portion of the number line between 2 and 3. Suppose we divide this into 10 equal part. If we divide this 2 and 3 part, that is equal to 10 equal part, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 only. So I divide this in 10 parts. Now we know that this 2.665 is lies between 2 and 3. So first mark the right that is will be 2.1. First we can write like that 2.1, 2.2 like that, that is 2.1, 2.2, 2.3, 2.4, 2.5, that is 2.5, then 6, 7, 8, 9, 10. Here is 10 complete. 2.5, 2.6, 2.665 is like that here. So if we want to represent on number line 2.665, that is like that here, this point, that is 2.665. So this is difficulty to observing these point of our division between 2 and 3 to have the clear view of the same. So may take a magnification glass and look at the portion between 2 and 3. It will look like the figure that is 2.6 like that. If we see the figure, this is shown like that, this is the figure. If we see, this can be represent number between 2 and 3. So we imagine to divide these again into the 10 equal part. The first mark will be represent 2.61 like that. Then after we can clearly visible the 2.65. So when we want to clearly visible that 2.65 here, so this is again we divide these part 2.6, 2.7 between these part can be divided to 10 equal part. 2.61, 2.62, 2.65 is like that. Then we find the value of 2.665. So this is the concept behind finding the number of 2.665 like that. So we take an example. Visualize the representation of 5.37 bar. If we want to visualize the representation of 5.37 bar, how we can represent 5.37 bar? 5.37 bar. What is the value of 5.37 bar? It means this is value of 5.3777 like that, so on. Okay, once again we proceed the successive magnification and successively decrease the length of the portion of number line in 5.37 bar direct. So it is located. First we see the 5.37 bar is located between 5 and 6. So first we see that is 5.37 bar is anywhere between 5 and 6. So first we write here 5 and write here 6. Okay. In the next step we locate 5.37 bar between 5.3 and 5.4. If we locate, that is number line 5.1, 5.2, 5.3, 5.4, 5.5, 5, 6, 7, 8, 9. If we locate between 5.3 or 5.2, now 5.37, it means 3 is here and 4 is here. So then we can consider that the 5.37 bar between 3 and 4 only. First we see the 5.37 bar located between 5 and 6, and next step we locate 5.37 bar between 5.3 and 5.4. It means here also there is any 5.3 value and then 5.4 value. In between the value of 5.37 bar also. 5.37 bar. So to get more accurate visualization of representation, we divide the portion of number line into 10 equal parts and use magnifying glass to visualize the 5.37 bar lies between the 5.37 and 5.38. This number lies between 5.37 and 5.38 if you use magnification glass. So we divide this portion number line into 10 equal part and visualize that portion. So we again the portion divide is 5.37 and 5.38 into 10 equal part and magnifies the visualizer 5.37 bar lies between 5.3677 or 5.3778. It means this part lies between 5.37 and 5.378. And more we accurately we have divided the portion 5.37 5.38 into 10 equal part and 5.377 5.38 के बीच में in between the number has, and now the visualize the 5.37 bar still more accurately we divide the portion of 5.377 and 5.3778 that in equal part and visualize the representation of 5.37 bar and locate that 5.37 bar locate closer to the 5.3778, then 5.3777 like that. So if we visualize that portion, that is the visualization of that portion. It means we here visualize that is 5.2526. Then also visualize that is 5.37 bar for visualizing, that is 5.37 bar, 5.377 or 5.379 in between, that is 5.37 bar. So we can proceed endlessly in the manner and successively viewing through the magnifying glass and simultaneously imagining the decrease in the length of the portion of number line in which 5.37 bar is located. The size of number of line B specify demand on the target of accuracy, and we would like to for visualization of the portion of number to the number line. So you might have to realize that by now then the same procedure can be used to visualize the real number or non-terminating or non-recurring decimal expression on the number line. In the light of a discussion and visualization, we can again say that every real number is represented as a unique digit on the real number line, and further every point on the number line represent one and only one real number. Now there is an example that is visualize the 765 on the number line using the successive magnification. Next, also visualize this 4.26 bar on the number line up to 4 decimal place. It means we want to visualize the 4.26 and 26 bar, like that. We can want to visualize on number line. This is also visualized in the number line, that is 3.765. Now we can perform the operation of real number in next video. Thank you.